Alright folks, welcome to Doozer Shop. I'm going to take the rocker box off the Colchester out from under the bottom of the apron, and I'm going to do some preparation for my modification of adding a tab or a tang to the bottom of the rocker box, which will lock into a locating slot feature to restrain the torque, the side thrust from the worm gear I've talked about in my last video. So I got you guys mounted high up on the camera there. I'm going to start pulling the apron apart, and you guys can join in and see what I'm doing also. So let's get at it. Let me grab some tools and let's go. Alright, I'm going to take off the locking collar on the feed rod. Maybe you can't see, but it's just a locking collar. And, there it is. I think I can slide out the feed rod at this point. Yeah, I'm kind of sliding it out. So this is the little 2-finger drive coupling that goes into the quick change box. That I'm going to set there. I guess, let's see, let me pull the rod. Everything's going. I got clearance down at the bottom end. You can't see, but my vise and everything, my floor vise is... Okay, now the shaft is going to enter the bushing, and I'm going to drop out the plastic nylon spacer. Alright. Alright. There's the nylon spacer. I made that from the solid. I got a big long piece of nylon of this diameter, and I just bored it in the lathe with a boring bar. I set that there. I made that. Oh, I guess I can take off, make it easier to take off the whatever this is called, this bar for limiting the drop of the rocker box. Got some Allen screws. All this stuff is just finger tight because I've been mocking it up, as you guys can see. Alright. And it's just kind of lock it in while I undo the bolts. Screws. Alright. So this is what it is, guys. And this rod, it just fits in a blind hole, is all it is. So that's cool, that works. Alright, so now when I loosen or I disengage the rocker box, it drops down. And, before I bought this lathe, or just when I bought the lathe, you could see in the paint of the chip pan, there's a scrape, a scratch, a score mark, where this rocker box handle had been dragging for quite some time, and there's a flat worn on the bottom of that handle. So that thing's been dragging around the bottom of the chip pan for who knows how long. And talking to one of my friends here about when I first got this lathe, the rocker box where the worm is, it was filled with metal chips and grease, because they had grease fittings on it. And I made the comment, I said, how in the heck can metal chips get up in there? Maybe guys using an air hose like crazy. And my buddy said, Well, this lathe was probably in an environment where they just let the chip pan fill up so much with chips that the chips were overflowing, touching the bottom of the apron, and just that's how it happened. I'm like, wow, yeah, I've seen lathes like that. I've seen videos online of lathes like that, of the chips just, you know, touching the bottom of the apron, which is crazy. That's just a lot of chips. Don't ever do that, folks. Don't ever be so careless and lazy, whatever the word is. Okay. I'm going to push the feed rod down a little more, and I think I can slide off the rocker box. Okay, so here's the rocker box, and inside the rocker box, if you guys can see, but when you insert the shaft, the feed shaft, the feed rod, this gear just floats in here, and there's a spacer washer and a spacer washer, and they're different thicknesses, so you got to make sure you don't mix them up, but they're a bit different. And if you put the thick one on this side instead of the thick one being over here, the gear mesh is off, and you can tell pretty quickly that you got the wrong spacer in the wrong area. And it's kind of good I'm making a video of this. Maybe if I take this apart in like 5 years for whatever reason I forget, it's just good to document it. Let's just say that. I don't want to talk about my memory fading, because I do forget silly stuff now and again. Alright, I'm going to set this rocker box on the bench where I'm going to disassemble it, and I'll come right back. Alright, and not like there's anything else to disassemble, but to document, I want to show you guys. That's the spacer that fits on the tailstock side. And then one night I was playing around with it and looking, and I decided that it needed another shim. Needed another 25 thousandths shim. I was talking about using a razor blade, which is 25 thousandths, and sticking it next to this washer and the bushing to set the end clearance of the rocker box, how it would travel in the apron. So this is kind of funny. So I did find a 25 thousandths shim. It happens to be brass, but you can see there's numbers on it. This is the face of an Ames dial indicator that was broken. The indicator was just spanked. And it was sitting on my toolbox, taken apart, getting ready to throw out in the trash. But then I brought my caliper over and I measured. It's an 1.5 inch bore, just what I needed, 1.5 inch bore, and the thickness was correct. So that was my shim. And if somebody takes this lathe apart, they're going to see, you know, numbers. In a dial, so I thought that was funny. I'm going to put this back on so I don't forget it when I re-put, you know, the rocker box back in. So yeah, this is a funky apron design with the bottom being open. I mean, it's a double wall apron, so the shafts are, you know, supported with bearings on both ends. See, there's such a thing as a single wall apron and a double wall apron. Cheaper lathes typically have a single wall apron where the wall is just this front surface, and the shafts are all overhung without a bearing support on the backside. And overhung loads are bad because your front bearing has to be really rigid because there's only one. So you always want to do fully supported loads or design things in double shear instead of single shear. But you know, it's not that hard to take this lathe apart. It's pretty easy. Oh, my point was also with the double wall apron. This is double wall, but the thing is, it's open on the bottom for this rocker arm, rocker box arrangement. So therefore, see, most aprons have real engagement dogs or engagement clutches, as opposed to the sliding gear teeth that mesh. And the advantage, I guess, is so you can have the apron where it'll hold oil. It has a bottom, and you can fill this up with oil. So I'm going to just make the assertion that this is a British thing. This open bottom double wall apron, you know. But as you've seen in my last video, the action of sliding these in and out, bang bang, is just, I love it. It's very positive. In sliding gears, not that bad, you know, not bad at all. The old transmissions in the 20s and the 30s were sliding gear, and then they came up with, you know, the dogs that mesh. So instead of the gears sliding, they had dogs coming in straight at each other that meshed. And then later on, of course, they had synchro mesh, which had little clutch cones that tried to speed up or slow down the gears before the dogs actually would come together. You know, whether you were upshifting or downshifting, it would that synchro mesh. But another tangent. So let's go over on the bench, and maybe I'll show you a little bit what my plan is. So meet me over there. Alright guys, I got the Colchester rocker box here on the bench. Kind of going to show you how it comes apart, or you know, what I'm kind of doing with it. So, like I said, that's the gear, and this is a keyway in there. I'm sorry, it's a key, and it's a special kind of key. It's called a feather. Alright? So I'm going to take that out. Alright, so there's the gear, and the see inside that long key. There you go. So a key like that is called a feather key, which is retained in the bore. Actually, it's one piece. So how would you manufacture that? Probably broach it with a some kind of broach that you drill it and then you'd remove all the material around. I don't know. It's best I can figure. But anyways, so that's the gear that takes the rotating motion off the feed rod. So there you go. So that goes there. There's a ground washer there for this side. I'm going to keep it with it. And there's a ground washer over here, which I'm going to keep on this side. So I'm going to set this off to the side, and we're going to put it back in, when we need to. Okay. So we got the box here, and this whole area, I think if I put oil in here, I know it cants up and down, but I think some oil would stay in here, when to lubricate that worm. We'll see. I didn't want to do it just yet, because then I'm taking it apart and oil will be everywhere. But
Okay. So now I'm going to flip it over. And on this side, so I was talking about these were oil ports. They were actually grease ports. Someone had screwed grease fittings into them to lubricate these bushings. And it just made a holy mess because grease holds chips, and it was awful. So I didn't even drill the bushings for connection with these ports. So you could just see the bronze bushing inside there. Because I figure I could just oil the shaft, and these would receive plenty of oil. So these I kind of abandoned. And here I just got street elbows screwed in here. So that, as I covered this in my last video, there's a little port that actually connects to here. So this is the worm shaft. So the shaft is pinned to the worm and the spur gear, and they rotate together. So that shaft spins, and so that's what I'm going to have little push lock 1/4 inch hose tubing, and I'm going to have external oil cups high enough where the gravity is going to, lubricate this one and this one. So that's cool. But what I'm going to do here is tap these to 7/16 fine thread, 7/16 20. And I think it'll work. I ran the numbers. So the OD of a 1/8 inch pipe is 0.406, 405, somewhere in that area. In the drill, for the tap drill for 7/16 20, I think is 0.391. So that's the OD of the pipe is 405, 406, but I don't think these are the threads aren't to that size as far as thread depth here. So I think I'm okay. So here's a 7/16 20 tap, 7/16 20 National Fine. So my plan is to, oh yeah, that'll work. All right, so this is the plan. My reference surface could either be the center line of the bores for the feed rod. Well, these are as they are. Somebody must have drilled these. I don't know. Well, hold on. Let's get a caliper real quick. All right. So let me kind of do some rough measuring. It's always good to get a feel just how centered are your features. I don't know who did modifications to this in the past. So this front surface is a flat surface. And we're going to kind of eyeball, unless I get a piece of steel. So I got a flat piece of something here. So that's approximately centered, and we're going to hone our approximate. Well, that's approximately centered too. And like I say, it doesn't matter. I could put this in the mill, and I could indicate these holes. I could put in a pipe nipple, indicate around it, and that's what I'm going to do. I'm just getting a warm, fuzzy feeling here, if these are close to anything. All right, so that's my next thing. I'm going to go over, I don't know which mill I'm going to use. Let's see if I can fit this in a vise or clamp it to the table. I want to level this surface to the table in the mill and pick up these holes and drill them out to that 390 tap drill size for the 7/16 tap. So the plan is this. I'm going to put a piece of bar stock on here, kind of like pretend the file is a thick piece of bar stock. So I'm going to bolt the bar stock on the bottom of the rocker box. And the reason I'm going to use these is it's the strongest part, thickest part of the casting. In the middle here, the wall is thin, and I could measure it, but I might as well use these because I know they're in the meat of the casting. So, and I'm not using them for lubrication, so I'm going to turn them into bolts, bolt holes to retain the piece that's going to have the dog tang tab on it. So picture a piece about like that file, but maybe 3/8 thick, maybe 1/2 inch thick. And in the center, I'm going to have like a drilled and tapped for an Allen screw, a hardened screw, something. So let me go and get this either on the table of a mill or in the vise of a mill, and I'll bring you guys back. All right, we are back over on the Clausing 8520 milling machine, and we have the rocker box. I set it up on the table of the mill to locate and drill and tap out those 1/8 inch pipe thread holes to accept our plate. So let's kind of take you around here and show you my setup. So let me show you from the side here. And I was a little bit lazy to remove the vise, and I had enough table room, I think. So basically what I got here is, let's give you some more light. I don't know if this helps. Maybe. Alright, so the rocker box has been set on some 1, 2, 3 blocks, okay? If you look around the back, I got 2 Swiss cheese, 1, 2, 3 blocks, just to space up the rocker box. Now, when I did some previous machining operations on this casting, I ground some flats on the back side, and that's how I'm able to space up the rocker box off the milling machine table with my 1, 2, 3 blocks. The 1, 2, 3 blocks are actually sitting on some ground surfaces, equidistant respect to the center line of that bushing bore. So it's flat on the table. Okay, and now I stuck a piece of 1 inch cold rolled shafting through the bushings. So as you can see, they're 1.25 inches inside diameter, and I just threw a piece of 1 inch through there to clamp off of. And the setup is the same both sides. So I've got my my table clamp, my strap clamp, holding down that piece of bar stock in the bushing bores. And like I said, I got the all thread holding in the T-nut and the T-slot of the milling machine table. And as long as the top of the clamp is level, you can balance it out with pretty much anything just to pack up the other side. So here I got just two pieces of shafting as spacers, and then I got a dowel pin on top. And notice I have the dowel pin oriented, so it kind of it'll take up some forgiveness if that strap clamp, table clamp, isn't perfectly level, and it's pretty darn close. I mean, you need to get it close. You don't have to, you know, get the world in an uproar about getting it level. But it's it's reasonably level, so as not to exert side forces, and you want to clamp down. You don't want it to pinch out sideways. So, oh, now let me go behind it. Actually, these really aren't necessary. I thought they would be. I've got some machinist jacks under this side supporting it for level. They're really just barely touching. They're not that tight. Let me kind of swing you over here. I got the same thing. I got a little spacer, and I got a machinist jack. And as you can see over here, I got the same thing. Yeah, right up tight to the vise, but it doesn't matter. I was just too lazy to take the vise off. But I got two spacer pieces, a round piece of aluminum. You know, that's just a packer for the clamp. And as you can see, I got that bar stock hanging out the other side of those bushings. And it's holding it to the milling machine table, nice and flat. So another thing I wanted to do is indicate that front surface. So where I got the paint razor bladed off right there, and right there, that's a virgin surface from the factory. So basically I indicated across from there. There's a little bit of paint on here, and I didn't bother to scrape it off, and indicated there. So I am at the same dial indicator reading. You know, the needle comes to 5 thou there, and it kind of humps up a little bit, you know, 6, 7, 8, you know, and it indicates 5 over here. So as long as you're the same on both places, this thing is straight in line with the, you know, the table travel. So that's good. And previously, and I was surprised how good those ground flats orient the table for flat, the rocker box for flatness. But I took an indicator and I went side to side, and then I went front to back. And this top surface is flat in two directions within less than 1/1000th. So I'm good this way, and I'm good this way, and I'm good across the face. So X, Y, and Z are trammed in. And the real reason I did the front, and as I said before, those holes will end up being where they are, but I want to get an idea when I make my plate if I have to offset the hole pattern in my plate a few thousandths one way or another when I bolt my plate on there. So I just wanted to show you my setup here in the Clausing 8520 milling machine. As far as so now I'll show you the next step once I get going here to get those holes indicated in. Okay guys, I got some dowel pins, gauge pins, put in those 1/8 inch pipe thread tapped holes, and I'm using a vertical face dial indicator, and with a long extended needle tip, and I've got it zeroed out. And sometimes those vertical face indicators are really handy to let you take a reading all the way around when you're indicating in something on the mill. So yeah, that's a good tip. If you ever see one reasonably priced on eBay, maybe you should jump on it and give it a try. But I got those pins fitting pretty snugly, pretty snug in the holes, and I'm going to drill and tap this for 7/16 20 thread, and I got my digital readout centered. Then I'm going to go over to the other one and do the same thing and make note of my spacing dimensions and my offset dimension from the center line. And it's about 30 thousandths offset from the front face that I showed you, indicated in the last part of the video. So I'm going to change this out and get going. Okay, I got the hole drilled and came out great. I used a size W drill, which is like 3/86. They called for a 25/64 drill, which was like a 390. So I'm like 4 thousandths to the tight on the hole size, just because I wanted to shoot for a, good 75% thread engagement, maybe even 80. But the taper nose, well, it's a plug tap, but the tapered nose of the plug tap fit right in the hole, no problem. I guess I can. And the hole's plenty deep. I bet you I got over 3/4 of an inch of depth on this hole. And yes, I could power tap it, but I'm not in a hurry. I don't want to screw anything up and tear anything loose, so I'm just hand tapping it. And this is a Whitney brand tap. I think it's the only 7/16 fine thread tap I have. Maybe not. I didn't do an exhaustive search, but let me take this out and blow out the chips. Looks good. Let me okay. I like that. Looks like I got another 1/4 inch to go. I'm about a 1/2 inch into it. I could finish it by hand, but I'll just finish it down here in the mill. And then I'll set up on this with the indicator, indicate the dowel pin again, and drill it and tap it. Alright, if you guys want to see me indicate the hole, we'll go on to the next one. So very carefully put the indicator into the chuck, and I'm going to grab the chuck key. Okay. So let's crank her over. All right, we're making contact on the indicator. Let me see if I can sweep it around. Let's see here. So that's going low. That's going high. I'm going to start moving it in until it stops getting high. All right, let's see. That's it. 5, 0, 2, 3, 4. Okay. So it's almost 5. You see where it actually goes. You know what? I want to go, if I come back over here, I'm going to go, well, first of all, I should be closer down to the bottom, okay? Hope you can all see that. I'm going to lock the quill. Alright. So, let's see where I'm sitting here. Alright, now almost the back side is at 5. And let's see the front side. So let me go get the side here. Let me set the side to 5. Alright. So that's 5. We go on the back. The back is at alright, so that's there. And it's a 10th thou indicator. So 0, come back down, come back up. So let me go higher here. Let me go 0 there, drops, comes back up. Okay, now I'm 0 there, drops back, and I'm 0 there. So if the front is 0 and the back is 0 and the side is -5, if I bring that up to 0, we should be pretty golden. Alright, now you can't see, I'm spinning the belt in the head. Alright, so look like 1/2 thousandth, 1/4 thousandth, 1 1/2. So let me cut that back to like 1. Man, this is, no. Alright, so there's exactly 1. Forget the side. The front is exactly 1. The side is 1/2. What's this side? This is going to be like more than 1/2. Yeah, this is 1 1/2. So if I go down, so that's 1 on the X. That's 1. That's 1. That's 1. Okay, so we got 1 thou. Now, when I move it back and forth, it's called a dither. I'm kind of just dithering it. 1, 1. We are 1 all the way around, so we're good. So that didn't take too long. And my readout says 31 thousandths off axis in the X, and it's 4.22, call it 6, spacing between the holes. I notice a lot of the holes on this Colchester lathe. They're not straight across from each other. They're offset by about 30 thousandths. And I wonder if that's on purpose. I just thought it was like somebody used transfer punches or Heim screws or something. Heinemann screws, whatever they're called, transfer screws. And they were just sloppy workmanship on the part of the fitters. But a lot of these holes are drilled 30 thousandths off. Maybe that's what they did for an orientation thing. I don't know. Yeah, that is dead nuts. Needle ain't moving. I hope it's still... Alright, there's 0. Yeah. It's working, folks. Okay, so that's cool. Now, the dowel pin has some lean to it, because if I go back up, I'm like 4 minus 1 minus 2. Yeah, it's got some lean to it, but that's fine. I'm going to, reestablish a nice straight hole when I drill it. And I know a drill is going to follow the hole to a large extent. Set this where I can be safe with it. Alright, let me pull out my pin. So on this mill, to save daylight, I bought a set of screw machine length drill bits. From Enco, and Enco was still back in the day open. I think they're Precision Twist Drill brand. So I'm going to lock the quill. And I'm going to drill with the knee because I think it gives me better control, at least until I get through those threads, the threaded part of the 1/8 inch pipe thread. The threads I just tapped over on the other side look really nice. I think that was done really well. Came out really well. Cranking the knee up here. Alright. 4.226 and 31.5 thousandths. So I'm going to lock the table there, snug the table lock there, and let's get to drilling. Let me turn on the VFD. I'll go a little faster. I don't want to go crazy. So my quill's locked, and I'm going to feed with the knee, at least until I get past the threads, then I'm going to hand feed. Here we go. I'm going to check that and see what it looks like. Looks good. I'm down about 3/8. I'm going to go a little bit more with the knee. Back it off. All right, I'm going to clean the hole out. I'm going to take the bit out. can just barely see the remnants of the old 1/8" pipe threads. Just barely. And mind you, I'm drilling with an undersized drill bit. So I can see the hole in the bottom, or at least where I stopped drilling. And it did straighten the hole out because I've got a thin margin on this side and a little bit thicker on this side. So I am straightening out the hole. And as I go, because I'm holding it so rigid, when you have a short drill bit and you hold it rigid, and when you feed with the knee, see if I use the quill feed, you get that bouncing because it's a 2-flute drill bit. And you don't get a straight cut. If you lock the quill, you have so much mechanical advantage, gear reduction, let's say, with the knee, and so much more rigidity that it's going to hold that drill bit and it's going to feed it with consistency. You're not going up and down with the quill hand feed. This is actually an old drill chuck. These knurled body Jacobs chucks, I think, are from the 20s, 1920s. Now I'm going to hand feed, trip over the air hose. I'm going to hand feed with the quill. Come on, switch. And I'm going to hold it and unlock it. Hold it with 2 hands here as I feed it. And when it hits bottom, the drill bit point hits the bushing, I'll feel it. That's why I'm hand feeding it the last little bit. Here we go. Alright, it stopped. So that means I hit the bushing. And, you know, I didn't cut it, I just touched it. Alright. I dig it. Trying to look down there. Yeah. Looks good. I can see where the drill stopped, where the point hit the bushing. You know, the lands of the drill are, you know, up maybe 1/16 or so. All right. Put the old tap in there. Good with that. I'm going to reach over here and go on this side. And I'm going to turn it on a little bit. And I don't have the belt in a low range, so it's not going to have the torque, but I'm going to start it. Alright. Turn the VFD off. I'm going to come back around this side. I'm going to reach over, I'm going to apply some downward pressure on the quill just to give it a little bit. I know it started, but I like to give it a little, at least on these first couple threads. I need to tighten the chuck more. Alright. Now. Alright. And it's cast iron, obviously, so I'm tapping dry. I shouldn't have to hold the quill down feed anymore. It's got enough engagement where it'll suck it in without stripping anything. I'm going to run it out. About halfway down. Maybe I'm 3/8 down. Threads look good. Alright. And like I said, I think this is the best place for the bolts. Well, they're screws because there's no nut. Because it's the meatiest, the most meaty part of the casting, the beefiest, the thickest part of the casting. Putting the gronk to it. Gronk. I think I like the knurled body chucks for hand use better than the fluted Jacobs of more modern affiliation. My left hand is stronger. You check it one more time. Pooh, it's all over me. All right. I got about 2 or 3 more threads to cut. And I'll feel it hit bottom. It slipped right there. Got a little tight, maybe I did hit bottom. Yeah, that is bottom. Boom. Alright, that's bottom. Back her out. Oop. Wrong way, Harrigan. Alright, good. Yeah. Now that I know I'm down, I'll take this out and get the air hose in there a little straighter. Alright. Kind of peer inside. My tippy toes. Yeah, perfect. I love to use the word perfect because that means things are good. All right. I'm going to shop vac this dust off of here. I'm going to write down my numbers on the marker board so I have them to make my piece that goes on there. Yeah. Nice. And I'm glad I went with like about 4/1000 undersized than recommended drill bit. Because cast iron, you need all the strength you can muster. All right, I'm happy with that. Let me clean this up and take it off the mill, and I'll bring you guys back. All right, I thought I'd show you guys the, I'm just gonna take it off the milling machine table, and I'll give you a look at my setup a little bit closer with the clamps and supports. Zoom you in. See, loosen this clamp. All right. Oops. So, let me see. And just a bar. And I guess I'm ready to pull this piece off. Alright, so that was basically my setup. Some height jacks, some machinist jacks, and some 1, 2, 3 blocks for resting it on the flat surfaces. Set it down here. These are the flat surfaces that I was talking about. So that's ground. That's ground too, but that's a little high. That's a higher surface. So I was registering off of here, and I was registering off of here. So yeah, I'm going to wash this up in the parts tank and get ready to make the piece of metal stock that's going to go across and fasten to the holes I just made. Just kind of rinsing it off, rinsing out the holes. It's not real good. Kind of a just so I know none of the iron chips got
anywhere. And just blow that off with the air compressor. You don't need to see that or hear that, and that'll be that.
Alright, and here's the dimensions for the hole spacing on my digital readout for me, just in case I forget them.
Alright, I got the rocker box cleaned off in the parts washer and blowing all the solvent off. I got some 7/16 fine thread bolts. They're the only ones I had. They're just, they're actually place bolts from a Ford engine flywheel that bolts to the crank. But anyways, just testing the thread. All the threads were cut very nicely. I got about 9/16 of thread depth. Let's see if I can. Yeah, it doesn't like that. But anyways, yeah, I think it came out pretty well. Always go the wrong way. But as a side note, these are pretty cool. These are called place bolts. I'm not sure why they're called place bolts. I've read that they were developed for the reciprocating vibrations of steam engines. But it's kind of cool. The engineering behind place bolts is it looks like a castle nut, but it's not. It's got like little slits in the head, and there's a dish in the middle. What that does is when the bolt is torqued and tension is created, the head deforms in on itself and collapses just a little bit and creates a spring effect. Well, it is a spring. And the reason that you want the head to collapse in on itself and stretch like a spring is because these are short bolts. And short bolts do not have enough length in them to store energy. See, what keeps bolts tight is they stretch, and when you torque them with twist, they stretch, and the stretch is stored energy, spring-loaded, energy stored inside the bolt. And because short bolts don't have the length, they don't have the capacity to store that energy when they're tightened. So even though this is a short bolt, place bolts, by allowing the heads to deform, have a springiness to it, and that stores energy. So the energy is stored in the flexing and deformation of the head. A lot of guys in the hot rod world that have headers, they have really short bolts. Header bolts are really short bolts. And headers, as a rule, if you're a hot rod guy, always loosen. The reason they always loosen is just this. There's not enough length in their bolts. If you look at the original manufacturers, cars with tubular headers, like a lot of OEMs use stainless steel tubular manifolds. I wouldn't call them headers, but they're tubular manifolds. And they're not a good stainless, they're just a rusty stainless. But nevertheless, they use tubular spacers, and they use long bolts because they know, because they don't want warranty claims, and it's just good design to have long bolts to store that stretch energy. So especially with exhaust, and the heating and cooling, creates expansion and contraction of everything. So that's why exhaust manifolds or headers or anything should have long bolts. If an engineer wants something to stay tight, he'll design it with the longest bolts he can. And even if you have to use a spacer and it looks out of place and goofy, he'll do it. But if you can't, a place bolt is a good secondary alternative. But anyways, thanks for watching Doozer's Shop. I'm going to make another video when I get the plate made up. I don't know if I got any material here. I should have something I can mill down. I don't want to mill down a huge piece of bar, but I'll scrounge around and I'll find something. So, until next time, this is Doozer's Shop.